I'll take it from here. Let me just real quick share my screen. Excellent. So I hope everyone can hear me.
Yeah, it's great.
Excellent. Good afternoon, everyone. Thank you for taking the time to join us here today. Before we start, I'd like to take a moment and thank the Softprom team for making this happen. On today's session, we will talk a little bit about Votiro and how we can help organizations when they're dealing with undisclosed attacks. But before that, just a quick intro. My name is Michael Tal. I'm technical director here at Votiro. Been with the company for the past 6 years. Votiro is a zero-trust content security platform, and we ensure all data entering or leaving the organization is secured, safe, and ready to use. We assume all files are malicious, and therefore our approach towards it is in a complete trust no file method. No matter where the file originated from, whether it's email, web downloads, or SaaS applications, we will be able to apply the same zero trust approach to these files, objects, and unstructured data. Today's topic of the webinar is how do we sanitize files from 0 days and undisclosed attacks. And before we're jumping into the weeds, I'd like just to align, everyone here probably already know that, but I would like to take a moment and just explain the timeline of an actual 0-day attack. So as you can see here in the chart, before we actually understand that there is any potential malware that can harm our organization, first of all, there's the application or the system itself, and there's the threat actors or the attackers that find the vulnerability in the software. So this is, of course, on the left-hand side where we see when the vulnerability is just introduced. So we have our threat actors that exploiting that vulnerability in the software or in the system, and then we have that gap that starts to happen from when the attack itself, or from where the actual vulnerability and the software is being patched. As you can see, there is a long way until the actual software is being patched by the IT teams. And of course, that major gap before the exploit is being even identified by the security tools, we need to see how we can close that gap. And of course, when the security researcher understand that there's a vulnerability that needs to be mitigated, this is where we are looking at that orange, the part in the middle. So this is where the vendor is already working on actually mitigating and find a way how they can solve that problem that was disclosed to the business or to the app in the company is working for. So we need to find a way today to see how we can close that gap, specifically when we're talking about undisclosed attacks. And you're probably asking yourself how we can do it, because if it is an unknown attack, how can something or someone can prevent it? Okay, so we will remember that or keep that in mind as we go through the presentation, and at least from a file-borne kind of attacks, or weaponized files, that if that allows me to say 98% of the businesses today are using documents as part of their daily basis. So at least if we can close that gap when we're talking about file-borne threats or file-borne attacks, if we can somehow mitigate that threat, we can help massively to the business when they're dealing with files that enter to their network and they're accepting them from third parties or whatever external source they may accept that file from. So this is our main goal, to see how we can help organization to mitigate that threat. And of course, we also need to bear this in mind, that even after the business already, or the organization itself, find a way to understand how to mitigate that attack and released an official patch, there is also a gap from when the actual patch is being released and from the time that those IT and security teams are going to patch those hundreds, thousands of endpoints with the latest security patches. So this is also something that we need to bear in mind, because it's not just a way of, okay, we now know that there's an attack that is being patched. It now means that all the efforts of the security teams are for enabling those patches into their systems, right? So again, that's something that we also need to understand and see how we can help when we're solving these challenges. And I have a great example for an undisclosed threat that happened last year. And if you're familiar with the Folina attack, and again, that Word document that originally sent to some targeted users in Europe, that was a malicious Word document that leveraged a vulnerability within the Microsoft Support Diagnostic tool. And in this timeline of attack, as you can see, we have a real life customer story that that particular Folina threat entered to the customer's network 2 days before the sample was uploaded into VirusTotal. And Votiro cleanses that particular Word document, eliminate that unknown threat from the Word file, and then basically allowing it to go through the system network or to the organization application without causing any harm to the business. And that's really something which currently still amazes me, due to the fact that after almost more than a week, only 40% of the AV engines and the rest of the detection tools in VirusTotal, they couldn't identify that Folina threat or that Folina vulnerability as a known threat. And even when we're talking today, we're still seeing some unpatched workstation or servers that are still vulnerable to this CVE. And again, I'm taking a step back right now just to re-emphasize on that particular portion. And you may ask yourself, how come Votiro cleanses the file before the actual first sample was even uploaded to VirusTotal? And the reason why that is happening is because we're not looking at the behavior or patterns or signatures within those files and documents that we're sanitizing. We're actually looking only at the known good content of the file. And in this example, if I may pause here for a moment, and maybe someone from the audience today would like to take a wild guess and tell, based on this chart, what is the actual file type that we're looking here. So again, feel free to jump in or post your answers in the chat. But of course, I will just pause here for a second and then I will move on. If anyone have an idea, just please put your answer in the chat. Excellent. So in this example that we're seeing here in the chart, this is an actual Word document. And in this Word document, you can see we have many objects that are part of the Office Word file, and they are based, of course, on the file producer standards, right? So we have the document.xml, and we have the endnotes.xml. We have the option to embed maybe media file. It can be an image file. We have, you know, other settings and configuration files that structure that document and let it and basically have the official standards of a Microsoft Word document that has the fonts, the right fonts with their size, the table, and all the embedded objects that can be part of that document. And these different objects can sometimes be manipulated by threat actors in order to carry a malware or carry, let's say, a potentially malicious code. And this takes me to the same story about Folina, because in the Folina case, what the threat actor did is it basically took one of the XML files and it pointed to another document, and in that case, it was an HTML file that was loaded as part of the Word document. So when the user opened the Word document, it would call an HTML file, and that HTML file basically holds a script that script leverage the MSDT, the Microsoft Support Diagnostic tool, and in that tool there was hidden that was the tool that had the vulnerability and the known, and it's at some point, of course, the known CVE that the threat actor leveraged in order to gain access to the victim's machine, right? So again, that document.xml, we have the option to have a target, to have an external target that can call maybe a different document, and in that document you can hold an HTML file, maybe another object, or whatever you'd like, maybe another image file that can be manipulated. But that object in that case called the HTML that run the script, and therefore that script allowed to run on the machine due to the vulnerability that was found in the MSDT tool, and then allowed the threat actor to gain access to the victim's machine. So Votiro, what we did in that case, we actually eliminated that threat before the Microsoft Support Diagnostic tool could even run on the machine. And how we did that? We basically cut the wire before the bomb actually exploded, right? So what we did in that particular file, we basically removed the call to the HTML file, to the weaponized HTML file, and therefore the HTML file would not even load on the machine, so the HTML file cannot even run the script. So this is the beauty on these on this, some of the secret sauce I can share with you, that we don't need to rely on, you know, behaviors or signatures. We can simply remove the potential threat before they can actually trigger on the machine. And that takes me into a zoom in on how we're actually doing it. That's the positive selection that technology that I explained, but we will now dive into detail how that process happens. So first of all, in that process, we need to understand what is the actual file type, what is the file format, right? Because if we cannot tell what is the file format, we cannot go ahead to the second stage, which will be to recreate the file based on its standards. And if we're looking at a good example, again, the Word document, we need to take all the sub-elements of the Word document and understand what can be the weak spot in that object, and reconstruct it to its known good form, based on the file manufacturer or the file producer standards. And this takes me to the third step, when we're actually extracting all the known good elements from the original file and putting them into a clean new template that we're creating. So that process eliminates all the potential malicious code that can still live on the original template. And only then, after we completely reconstructed the file based on the file producer standards, and of course, from a fidelity test, from functionality perspective, all these capabilities remain intact. Only then we can be sure that this file can be sent to whatever end location the file should go. And whenever I'm saying end location, that can be the end user's mailbox. That can be through web downloads when the users are downloading files from maybe their SaaS application, or maybe if that's a customer-facing portal, when someone, and a customer uploads his personal copy of driving license or identity card, and then there's a system in the backend that gets all these claims, all these forms that are uploaded, and we're sanitizing those files and different documents and make sure that they are being sent to those locations. Right. So I'd like to take a moment just to explain, now that we're familiar with how the process goes, on the way that how we can connect and help to mitigate those types of attacks. And one of the ways to do it is by email, right? So if we're getting an email with malicious attachment, and today, as you know, more than almost, I would say, 80% of the threats or the malwares that are starting the actual attack on the on organization, on the victims' machines, are coming from an email, from a malicious email that is being sent to a user. So this is the first way to start. An external sender or an attacker is sending a malicious attachment to the organization. In front, we have Votiro's email connector that accepts all the traffic. And again, it doesn't really matter where the file originated from. We will accept all these messages from wherever they come. We will make sure those files are sanitized, and then they are being sent to the end user's mailbox. And of course, when we're talking about that process, we need to of course, to ensure that we're not harming at any point the business productivity. That process of sanitizing the file and sending it to the mailbox happens in almost real time. For the average business document, that process happens in sub-seconds. So if we need to compare that to, let's say, a sandbox, that detonation process takes minutes, that's, of course, something that we also need to consider when we're looking at a security product, right? So we want to ensure basically two things right now. From a security standpoint, of course, we would like to make sure that all files are being sanitized and they are accepted securely and safely to the business. And of course, second of all, we don't want to harm the business productivity. So in case we need to have those files in a safe, secure, but also very, very, very quick in terms of when we're originally accepted them, that's also something that we need to consider. And therefore, that process also happen in sub-seconds, as I mentioned. Another way to have that, to have files to accept to the organization is, of course, as we mentioned, from web downloads. And again, as we're taking that example for a corporate user that requests a file from the internet, in this case, what is happening is that request gets to a server, to an external server, but before the actual file is retrieved back to the corporate user, that file is being sent to Votiro Cloud solution or Votiro on-prem solution. We will sanitize the file in sub-second, and we will send that sanitized file back to the user. And of course, we need to need to differentiate between a complex file and maybe the average business document. So when we're talking about the average business document, we're able to retrieve those files in sub-seconds. Of course, that time can change based on the complexity and the size of the file. So if we're talking about 100 megs or even a couple of gigs that we need to retrieve, that of course add latency, but still we need to ask ourselves, again, if we want to have that vendor protecting us from those attacks, we need to ensure that those files are being extracted, look deeply into those different elements, and then only then accepting them back into the corporate user machines. All right, so when we're talking about the different file types and different objects, and again, all the file formats in the common daily basis or daily task that we need to accomplish, we're talking mainly on Microsoft Office documents that can be Word file, PowerPoint, Visio, Excel, and so on. Of course, Adobe PDFs are common as well. AutoCAD files for engineering files, which means the DWG or DXF files, different images that can be vector images such as SVG or WMF, EMF, but also JPG, GIFs, TIFs, and so on. Archive files that can contain different types of objects, and those should be inspected closely because they can carry lots of different elements. So we're talking about zip files, 7-zip file, gzip, RAW files, and so on. So all of these container files should be looked and inspected when they're accepted to the business. And one more thing which is very important to talk is the password protected files, because we're seeing options for threat actors to get into organization by carrying a password protected file. So it's really easy today to bypass a security solution that will not be able to look deeply into a password protected file. So today it will be basically get into quarantine, or the other option would simply to accept it to the business. That's basically the two options. So we actually have a solution for password protected files. And when we're getting a password protected file, we're first of all, we're identifying that this is the case, that the file is protected with a password. And then instead of sending the actual password protected file, we replace it with a branded blocked PDF template, which is being sent to the user. And the end user can interact with that replacement PDF. And when the user actually click the PDF itself, it will open a self-service portal that Votiro serves. And in that particular moment, the user will be asked to provide and type the password for the file. And once the user does that, in real time, we're sending the file to Votiro's API. We're using the password that was sent in order to decrypt the file. We will sanitize the file, and then we will re-encrypt it with the same password and deliver it safely to the end user mailbox. So this is another way for us to make sure that the organizations are kept safe, but still allow their end user to continue and do their tasks safely and securely. So that summarizes the what I wanted to discuss today. And without further ado, I think it's a great segue to move into the live demo that I've prepared for today. And before we're jumping into that, this is just a glance on the Votiro platform, where you can see all this nice data that we can ingest from anywhere, or from any cloud application, or from any on-prem storage that we're working with. And as you can see here, in this lab environment, we have those different channels that Votiro can accept traffic from. And this is just to give you an idea on how, as an API-centric layer 7, we're able to connect easily to any existing workflow and be able to sanitize files and accept them safely to the business. And right now, I'd like to show you Votiro in action. So let me just explain what I have here today. So today, what I did is I took a photo, I took an image that I downloaded from Google earlier today. I just typed Votiro in Google Images, and I came up with that PNG, with that image file. But what I did is I actually manipulated that .png so it won't be that innocent, right? So right now, let me just double-click that photo. And you can see that immediately as I double-click that photo, it simply opened my photo viewer and it shows the Votiro logo in the screen. But what if I tell you that that image file is not that innocent as you may think? Because if we're looking deep into that Votiro image file, you can basically tell that it contains some sub-elements that holds an embedded data into it. And let me just share with you what I'm referring by saying that. So if I go ahead and I'll navigate to my 7-zip application where this file is actually saved on my machine, you can see that we have here the same Votiro logo 1.png. But if I will go ahead and I will double-click that file, you can see that now it has a secret, quote unquote, .lnk file. And for those of you who are who don't know what is the .lnk file, this is a shortcut file. And using a shortcut file, you can call a process. You can call a process that maybe then can call a different process, or that, let's say that process can call an external server that will download a file to your machine. And of course, at some point, you may leverage it to execute on that machine. But right now, what I did is I just manipulated it slightly. Because if I will go ahead and I will double-click that .lnk file within that photo, what it will do, it will simply spin up a process on my machine. And in this case, I just manipulated it slightly, you know, as again, a quote unquote white hat hacker. I didn't use a malicious activity right now. I just called a legitimate Windows process, which is the calc.exe. But think of it a little bit further. If I would maybe call a different file that can again actually communicate with an external server, and from that point it can be less legitimate. But this is again just to give you an idea how easy it is to go ahead, manipulate the file, and just embed something which simply shouldn't be there, right? We can get that image file from our graphic team, our third party that we're working on, and right now they have a new design for our website and just wants us to see that. And of course, I'm not pointing any fingers to our beloved graphic designers team, because in some cases those groups can be targeted by another, I would say, by another entity, and this can be the attacker. So the attacker injects himself, basically takes over a legitimate business. It can be, again, our graphic designers teams, or it can be a law firm, and it can be maybe an insurance company, and so on. And in that case, he basically injects himself and send me something that I'm expecting. And I will, of course, I need to do my job. I will go ahead and I will open that file without even knowing that this file can be, a problem to my business. And again, that's back to where we start. So right now, what I'd like to ensure to my business, that these files that are being accepted are getting clean, safe, and I'm able to open them without thinking twice if those files can be malicious or may have some suspicious elements within those files that at some point may trigger and cause harm to the network or entirely to the business itself. So what I'm going to do next is I'm going to close that calc.exe process, and I will close also my 7-zip file. And what I did earlier today is I made sure that I will copy that same .png file to a remote server where we have our box account. As you can see here, this is I logged in to a remote server where I have my box account. But today, what I want to show you is that Votiro is natively integrated in Box. This is again just to give you an idea on how Votiro can work closely, because Votiro as an API solution, it can ingest traffic from these different SaaS applications. In this case, we're connecting natively with Box, but same can be achieved with other applications such as Salesforce, Teams, and all sorts of applications. So we're ingesting the traffic as close to where the data originates. And in this case, I'll go ahead and I will simply upload that same Votiro logo 1.png. And I have here my file repository, and this is the same file that I just showed you in a moment. So let me just upload it right now as we speak. And as you can see, the file is being uploaded right now through the box account of mine, right? So again, I just as a user, I uploaded this file. Maybe now I need to share it with another colleague, or maybe I'm expecting that file from from another shared box account. So all sorts of data that can be shared here are the files that can be exchanged between maybe colleagues from the same company or from different companies. So that process that happened just right now, and we even could not tell that something happened here, but what I'd like to tell you is that file got sanitized as I just explained from moments ago. So this file here, as you can see, is already sanitized. And if I'll jump back into the Votiro's console, so let me just do it right here. If we're looking at the Votiro's dashboard right now, and I will jump into the event, you can see that this is actually the Votiro logo 1.png, that file that I just uploaded right now. And we will dive deep into the full details. If I click here into the view full details, you can see that we have the Votiro logo, Votiro 1.png, using the default policy. And again, we can apply different policies for different types of channels, right? In this case, my box integration works with the default policy, but we can define which sanitization policy to apply based on the ingestion point. And as you can see, we have one file that was sanitized, and this file processed in less than a second, actually 0.1 second to be precise. And we see we have a detailed report on the actual file name, the request ID, the file type, the size of the file, the hash of the file, but also the ingestion point, or where the file originated from. And in this particular case, you can see that's the box connector. That's where I ingested the file from. And last but not least, you can see that we have the data processing log that basically tells the story of where the file started or where the file originated from. It was uploaded to the box account. We true typed the file, we ran it through AV scanning, and then we processed it safely after we reconstructed the file. But before I move on, I would like just to show you from the end user perspective why I said that this file is now cleaned from any malware, because this is just to show you that the sanitization process happened in almost real time. And if I'm going back to my remote machine, I can show you that this Votiro logo.png file is now the Votiro logo, the sanitized version of the file, you see that it has the V2 tag next to it. So if I'll go ahead and I will just download the file, if I need to retrieve it to my machine right now, I will choose just to download the file. And you can see that I'm able to download the file. But what I want to show you is that this file does not include any threat right now, or it is clean from any potential threat. So first of all, again, I would double click the file. I will show you that it still opens as the same photo that I showed you previously on my working machine. And what I will do next is I'm going to show you that if I'm navigating to the 7-zip application, to the same exact folder, and I will double click that Votiro logo 1 PNG, it will simply open the photo, which means the underlying .lnk, the shortcut file that originally was part of this file, is no longer there, because we sanitized the file, we reconstructed the file back to its known good state while removing any data or any embedded object that simply shouldn't be part of these files, or in this particular example, in that PNG file. All right, so this is again the Votiro logo, the sanitized version of the file. And if I'll jump back quickly into the console, I would like to just show you here, if we're jumping into the policies page, that you can apply those different types of policies based on the common file types that your organization deals with. And in this case, again, we use the default policy, but we can use different policies for different use cases. So I'll pause here for questions.
Yes, we have in Q&A section, if you could open, but also I can repost it. What is the licensing algorithm? And of course, everybody else welcome to post their questions in Q&A section.
So today,
what's the licensing algorithm? Yes, that's the question.
Sure. Excellent. Thank you. So first of all, I have also Mike here also from the team. So Mike, if you'd like to go through that, of course you can go ahead, but if not, I can address that.
Sorry, for the licensing piece.
Right. Yeah.
Yeah. So licensing depends on the actual use case. So Michael mentioned very nicely earlier on the different use cases of Votiro. So it depends how the file comes into the organization. If, for example, it's email, then licensing is based on mailboxes or users, if you prefer. If we have a use case where the file comes, let's say, from the web downloads, then again is the number of users. If, however, it comes through a web portal, when we don't know how many users are actually using the web portal, but we see only the files that come, then the licensing is based on the number of files. And in some cases, when we don't even know the number of files, but we see the volume of the files, then we go with based on volume-based licensing. So we've got a number of different options, again, depending on the use case, the actual solution, a Votiro solution on the back of it. I hope that makes sense.
Thank you very much, Mike. Any other questions?
Yes. Not in the moment, but yeah.
Yeah, we have.
Okay.
Ksenia, we have questions. What about GDPR compliance?
Great. So for GDPR compliance, the options are very robust, I'd say. So usually the way our SaaS offering works, our hosted SaaS offering works, is that we have different clusters that are deployed in different regions within the globe, right? So we are hosted today in a famous cloud provider, and we have elastic clusters that are deployed in different regions. And in case we need to make sure that the data does not leave the region, we're able to support that by having those elastic clusters deployed in the same region. For more restrictive, I'd say, kind of data privacy regulation perspective, what we can do is we can basically deploy the solution in an on-prem or in the customer's data center or in the chosen customer's private cloud in order to ensure, again, that the data does not leave the customer premises, or again, if that's the data that could not be sent to a third party, or in this case, the vendor's cloud, that in these cases, we ensure that the data would not leave those regions and will remain in the customer's or business premises. Does this make sense? Perfect.
Yeah.
Just a little note on that, as far as the GDPR. So Michael mentioned about, you know, where the clusters are. We basically do not take a copy of the information on the documents. We don't keep a copy of that information on the document, right? Therefore, we don't extract any information from the document. We don't keep any of that information ourselves. We're actually not interested on that. As Michael said very well earlier on, we are not actually looking for potential threats in the files and documents, but we know the good state of the document, and we just reconstruct them based on that. So we don't have access to the information of the document. We don't take any information of that document. So we are GDPR compliant. So all customers, partners who feel you know, secure with that, because no information leaks basically goes outside of their premises or their cloud as such.
Thank you.
Any other questions or requests from the audience today?
Okay. Yeah. If you have any questions, you can write to marketing.softprom.com. And thank you for your joining. Thanks.
Thank you very much for the time. Thank you very much for the time. Appreciate it. Hope you enjoy it, and I wish you a great rest of the day. Thank you, Softprom, and thank you for everyone who joined.
Thank you, everybody.